you a subscriber.
All right, so here's the electron cloud, but inside the cloud you do have these levels, and we kind of visualize it like this. So it's pretty handy to use this, even though it's not exactly right. So here's the best way I can explain this. So every level has its own bundle of energy. So think of a hotel. You have floors on the first floor, second, third, fourth, fifth, sixth, seventh, and think about how much money it would cost. All right, so just here's the analogy. Every floor on the every room on the first floor, $100 a night. Every room on the second floor, $200 a night. Third floor, $300, $400, $500, and then seventh floor would be $700. It's the same way in atoms. So this first energy level has the lowest amount of energy. This has the next, this has the next. So as you move out, as you get further from the nucleus, so what does that mean? Moving down the periodic table, that's your periods, that's your levels. It requires more and more energy. So because the word quanta basically mean bundles of energy, that kind of defines the most current model, because back here they didn't talk about energy so much. Yes, they call them levels and energy levels, but these bundles of energies, that's a newer concept. So you may be confused, and that's fine. All I'm trying to do is explain what's this word about. It's a bundle of energy and how it applies to this and that model. So it applies to the levels, the shells. Each shell has a different amount of energy. That's all you need to know right now, okay? So we will talk more about that down the road. One more thing I want to add before we kind of shift gears a little bit. This is the most important part of the current model. So, electrons, so again, this is the current model. Electrons are found in regions of space outside the nucleus. Electrons are found in regions of space outside the nucleus called, anyone know?
Shells.
It's something smaller that's on the shell.
Orbitals.
Orbitals, very good. Guess where they got that name from?
Orbit.
Yeah, because they
Big
first
ball.
said, okay, these things are orbiting, and then they kind of took that name and applied it to a different, slightly different concept. So they do not orbit, electrons do not orbit. However, they live, I say they live, in these little regions, these little spaces called orbitals, and they're confined to that. They can't leave the orbit. So the analogy I use is the rooms in a hotel, or the classrooms in a school. So right now we're in a classroom, this room we'll call an orbital. So what would that make us? Electrons. Now you can only have 2 electrons per orbital, but that's okay. So orbitals are on the levels. So you have your 7 levels, and then within the levels, so just like floors in a school or a hotel, you know, this floor has a bunch of classrooms. So off the hallway you have rooms, and that's what these are. So it's a good analogy to kind of visualize what the heck's going on, except it's very different in reality, but that's just the analogy. Yeah.
If each level has more and more energy, how come some atoms have like 18, 32, then go down to 12, when 32 have more than 12?
Yeah, so the amount of energy required for that energy level doesn't depend on how many electrons.
Wait, so are some electrons
So
strong?
think about a hotel, okay? So let's say we all go into this hotel, this analogy, but I don't want to spend $700 on the room. So we're all going to probably stay on the first floor. So maybe one of us, I don't know, maybe Shane's like filthy rich. He's like, you know what? I'm gonna get the $700 room. See you guys later. So we're all on the first floor, but he's way up on the 7th, just because he has the money to do it. So the number of electrons doesn't really indicate the amount of energy. It's just they have enough energy to be there.
So some electrons are more powerful than
What do you mean by powerful?
They have
or
more
even
energy.
having more energy.
Oh.
Yes, sort of.
Yes,
Yes,
That was
yes.
hard for you to say.
Yes, yes.
Well, what do you
But
We'll get to depth in this.
less because it's a negative?
Wait a minute, but wouldn't the outer ones be the weakest? Because they are the...
well,
Oh my god.
so
Brimstone
the outer
is-
ones are easier to remove. but the energy level they are on requires more energy for them to stay there.
Then how are they easier to remove if they have more energy?
It's a good question.
So wait, it's
How do they have more energy if they're negative?
Don't get enough of this
so
guy.
wait, do they like
Wouldn't
if
it
they have
be
more
a
energy?
less-
That means
lesser
that they
charge?
move faster. So like if
You
you're
wanna sit
moving
down.
faster, it's easier to get out of the orbit.
It's more
Well, they're not orbiting, but
Oh,
yes,
but-
you can think of it that way. Yeah, that's a good analogy.
If they're moving freely around like in the cloud, how are they really in this like defined level?
Oh, because they cannot get out of this. So, because math says so is the answer. Math has defined this, and there's 4 types of orbitals. They're called S, P, D, and F. Those are the names of the orbitals, and those orbitals have different shapes. So the S orbital looks like a sphere. So the electrons in S orbitals buzz around and move and spin, but in a spherical configuration. P orbitals look like balloons tied together. D and F look like more balloons tied together. So the shape, like if you can imagine 2 balloons tied together, that's kind of the shape. So they're stuck in that shape unless something happens to them. Unless they're forced to leave. All good questions. We're moving on.
Good stuff.
Okay. All right. So, again, these are good questions, but it's hard because you need to know more, and I need to be able to teach more to understand and explain it. So it's hard to. We can't explain that yet. So hopefully, the more you learn, it'll all make more sense. All right. So this is the probably the most important thing to learn today. Is the most current model. Is define these spaces called orbitals. And the only thing I want to add to that, so I'll have it kind of branch off here. I need more room. So off of the word orbital, all right, off of the word orbital, I want you to write this. The highest probability of finding an electron is in an orbital. So the most current model is based on probabilities and a lot of math, and the shapes of these orbitals, like I was just talking about. Regents chem doesn't even come close to covering all that. You just need to know basically these two sentences here. That there are orbitals, electrons are in them, and if you were able to go quantum, the Ant-Man movies, if you were able to go quantum and find an electron, you wouldn't look anywhere except in an orbital. The analogy is, you want to find a student right now, where would you look? In classrooms, not in the hallway. Maybe there's a couple, but more kids are in the rooms than in the hallway. So the highest chance of finding an electron is in an orbital, but they're moving around inside that orbital, they're spinning, and there's different shapes, and there's a lot. This is pretty complex, but we don't need to get into all that. Okay? So, again, let me recap. What do you need to know? The name of the model, orbitals are on the levels, and electrons are found in orbitals. That's what you need to remember.
Okay.
Okay. Good?
Yep.
Okay. All right. So we're going to leave this this stuff alone for a little bit. Now we're going to talk about radius. When I say radius, what do you think of?
Middle.
Sorry.
Okay.
Circle.
Okay. I'll
Radius.
make it a geometry.
Circle.
Go ahead.
Like-
Elaborate.
Like a circle, and then
What I
you
said.
draw right to the middle,
That's
a
the
line
radius.
straight to the
So
middle,
if here's a circle, what's the radius?
Oh, it's like distance to the middle, right? Half kind of.
Diameter.
Yeah, that's what I think. Let's get the diameter of it, and then let's take half of it, right? So
Yeah.
this would be the radius.
Yeah.
Like isn't like
Yeah.
the diameter roughly 25,000 miles? and
Yeah. So okay, yeah. Everyone, you guys all know what
This is
radius
chemistry.
means. Okay. So stay with me, focus. So let's think of atoms as little tiny spheres, even though they're really not. We're gonna go with that because it helps us visualize it. Okay. So some atoms over there are really big in comparison to others. Now just take a guess. Who do you think is one of the smallest atoms over there? Hydrogen. Who do you think's next?
Helium.
And if I told you helium is smaller than hydrogen, would you call me a liar?
Yes.
No.
Probably.
No, because
Yes.
you're
Because I'm a chemistry teacher.
Yeah.
Yeah.
You're a liar.
Write this down, please.
Helium has
Knowing me, I'll
Oh, it's good. It's good. Good questions. You know what my daughter and I were talking about last night?
Wouldn't they be the
No,
same
not even.
size?
Chemistry.
Atoms.
Yep.
Like
And polymers.
oh.
I feel so bad.
And she was like, is that made of atoms? Is that made of atoms? I'm like, yep, everything is. Everything you point to. She's like, is that? And then I said, well, is this metal water bottle made of the same atoms as this plastic
How
toy?
could you?
And
How
she's
dare
like,
you?
yeah. And I'm like, no. Metal is made of different atoms than plastic. Those are, probably carbon and hydrogen structures. She's like, what's a structure? And I'm like,
How you
"All right."
change your voice to sound like her is hilarious.
I never thought of that. From your perspective, it probably is. Anyways,
We need a video of her talking so we know what her actual voice
she's
is.
gonna be coming in. I'm gonna have my babysitter, I think, bring her in the week before Christmas. So, anyways, yeah, I'll give her the
If I just like ask her
Go
a
ahead, teach us
random
about
chemistry
atoms.
question, like, is that made of atoms? She's gonna say yes.
Maybe, I don't know. Maybe. She likes the moon and stars, we'll talk about that. Alright, here we go. Okay, so yeah, helium and hydrogen, they have really small radii, right? That's the plural. Who do you think's really big?
Something like
OG.
Uranium's really big.
Radon.
Yeah. So where do your eyes go when you think small? Top.
Smaller numbers.
What about smaller numbers? What about big?
Bottom.
Bottom, right. So you guys have you've learned here, what do the periods mean? That's the number of
Electron shell.
shells, layers, right? So down here they have 7, up here 1, 2, 3, 4. Right, the electron configuration tells you that. Okay? So that's atomic radius. So I think it's easier to understand that as you move down, they get bigger because there's more levels. I think, you have a single, 1-floor hotel or 7 floors, 7's gonna be bigger. I think you get that. But now let's compare the two of these. So let's write general statements, then explain it. All right. So in general, cations are
Positive.
good, very good. Do they lose or gain electrons?
Lose.
How did they become positive? They lost electrons. Do you think cations are smaller than atoms or bigger? Smaller, because they're losing electrons. All right, so cations are smaller than atoms. So that hopefully is making sense to everybody. If you start losing electrons, you might even lose a whole shell, right? Peel a layer off of an onion. It's going to be smaller than it was before. What about anions? Right. Anions are bigger because they gain electrons. They're bigger than atoms because they gain. They may even gain a whole shell and they get bigger, right? If you add a layer to something, it's going to be larger. Again, think in terms of spheres, okay, or the Bohr model with all the rings there. All right, so let me give you 2 examples and then we'll see what we have time for. Hold on before you get us going. So Ca versus Ca plus 2. Underneath it, I'm going to write either larger or smaller. So Ca versus Ca plus 2. Who thinks they know? Who's bigger, who's smaller?
Smaller, bigger.
Yeah, Ca is larger. Ca plus 2 is smaller. Here's why. Ca is 2882. What about Ca plus 2? 288. It lost an entire layer. It lost an entire level.
Yeah.
So this has 4 levels. This only has 3. So does it make sense that this sphere, right, this atom is going to be small? That makes sense to everybody?
Yep.
Good. Now the rest of this conversation makes sense, but it's a little more confusing. So I'm going to use you as an example first. I need a tape measure. All right. I need 1, 2, 3, Jake 4. Stand over there. Like huddle up over there.
Me too?
Yep. Yep. Oh yeah.
Alright, so I'll call the play.
What are you doing, Tyler?
Watching the video.
1, 2,
Quads
3,
left,
4.
zone right.
Go over near the do not open sign.
Quads left, zone right.
Oh, God.